Hey guys. So I realized while I was editing and uploading the first 6 lectures of Unit 2 here that I had neglected some information that I think will be very helpful moving forward. So I decided to record some supplements and stick them in the middle there. First up, we have ionic compounds. So sodium and chlorine goes to make NaCl, Na1+, Cl1-, and it's called sodium chloride. So, for ionic compounds, I expect you to be able to do all 3 of these steps, right? With the exception that if we're talking about multivalent metals, like iron or lead or any of the other transition or post-transition metals, you aren't expected to do this, going from the elements to the other 2. But I neglected specifically how you can determine the charge of the multivalent metal. You can probably figure it out, you're smart guys, but I wanted to go ahead and spell it out clearly just in case. So let's look at MnN. Okay. So, what is the charge on manganese here? Well, for nitrogen, it's fairly straightforward. It's, you go to the periodic table, and you have nitrogen, oxygen, fluorine, neon, 1, 2, 3. That gives nitrogen a 3- charge. Or, let's go ahead and make it -3. Okay. Now, there are 5 nitrogens, so you multiply by 5, meaning that there is a total of -15. Okay? Which means that in order to balance it out, so nitrogen gives us the -3, there are 5, together that gives us the -15. Which means that in order to be neutral, to balance out the compound, the manganese needs to give us +15. There are 3 manganese, so you divide by 3. This is looking sort of upside downish. Let's see if I can't make it a little bit clearer. There are 3 manganese, so you take 15, you divide by 3, that's going to give you +5. So that's the charge on the manganese here. Okay, so that's going to be manganese 5 nitride. It's not the most elegant, but I haven't really found a better way. Or have I? You could always just reverse these. But you have to be careful because that won't necessarily always work. Okay, so for example, FeO. Okay. If you just, take them up, then you would get 1+ versus 1-. That's obviously not the case. But what you could do from there is you say, okay, oxygen needs to be -2. So you multiply everything up here times 2. That will get you 2+ and 2-, and that would work. So once again, I want to stress, the method you use, so long as it isn't cheating, to get the correct answer doesn't matter. So long as it always gets you the right answer. But let's see if we can't come up with some more possibilities here. This is one of the ones where it's going to work just fine. You bring the charges up, or you bring the numbers up, and that will get you 2+ and 1-, and that's absolutely correct. This would be lead 2 chloride. Let's see. What about this one? No, that doesn't mean water closet. It's WC. Well, you look at your periodic table. You have CNOFNE. 1, 2, 3, 4. So carbon is supposed to be -4. So in order to balance it out, tungsten needs to be +4. So this would be tungsten 4 carbide. Bringing the numbers up is probably not the way to go, because you're still going to have to do over here, the jumping around and finding the charges. I think your best bet is going to be, a B, M, B plus times M gets you Q. Q divided by N gets you A minus. Okay. Oh no, I got the charges backwards. That's A plus and B minus. Okay. I really think that this here is the best way to go, because you're going to have to do all that sort of stuff anyway, finding the charge on the anion and using that to figure out the charge on the multivalent metal. Okay, I think that covers it. That's everything I wanted to cover for our ionic compounds. So, see you in a bit.